To be honest, no. Actually, I heard of near-field microscopy during my PhD thesis, but I wanted to improve the resolution or break the diffraction barrier in a system that used objective lenses. So this was very important to me. And I also felt that near-field optics is done by so many clever people, brilliant guys, I wouldn't be able to compete with them. Well, the simple answer is that I didn't have a lab in the 90s. And so I was a freelance postdoc. And then I got a lab in the late 90s in Göttingen. But there, of course, I could concentrate just on a single project. And of course, the STAT was the project that was actually my thing. And that kind of was decisive for my survival in science. And so I couldn't have embarked on a couple of projects at that time. But I followed the field. And in those days, I must say that the single molecule community and overcoming the diffraction barrier were quite disparate. They had nothing to do with each other. They were going totally in parallel, and the link was made much later. In a way, I was lucky that biologists believed that I would eventually be successful, and so I had biologists around in the institute in Göttingen. And so the first real collaboration, I must say, was with Jan, who's a neurobiologist, and we worked about 2 years to get our project going and eventually published it. And it became the first application of super resolution to a biological problem on synaptic vesicles, to be precise. I think as a physicist, you're happy to do proof of principles, and that's what I did first. And I must say, I took a lot of reward and personal satisfaction from having done the basic principles, because I want to know whether it works or not. And the applications have never been that close to my heart. But of course, I realized that the methodology would be in a dead end if no applications would be done, and this is why I kind of, sort of half-heartedly embarked with people doing applications. Having said that, there are selected applications that I do participate, but so my strategy in the last 3-4 years has been to get a company going that disseminates the technology, and people should do the applications using commercial systems. I was part of the confocal community, not so much of the near-field community or single molecule community, which was evolving around that time. And so my stuff was perceived as an improvement over the standard existing confocal systems. And in retrospect, I must say, they watched me reporting one progress after the next every year. But actually none of them, with a single exception, Mats Gustafsson, really followed that path for many, many, many years. And this development was made in a community, so to speak, with feedback from community that didn't really engage in the topic. Possibly because they saw that in the end it would not work to the extent that I had hoped, or so that this could have been a reason. But it's a fact that, with the exception of Mats Gustafsson, no one until, I would say, 2005 or so, when Eric Betty came in, literally jumping from the near field to the far field, then the field got traction. The conference I went to was a focus on microscopy. In those days it wasn't called like that. It was called confocal microscopy, 3D imaging meeting or something. But it became the focus on microscopy. And those people were very much down to earth. They had all of applications of lifetime imaging and FRET imaging. And there's one or two little guy who were talking about overcoming the diffraction barrier, and this was kind of exotic in those days. But if you go to that meeting now, you will see that 80% do some sort of super resolution. It's a very interesting field. So it went different directions, plasmonics and the rest. And I'm following the field with great sympathy. Personally, I feel it's not my area in a way, because I have different interests right now. But I very much hope that new concepts come up and that it evolves as rapidly as ever. From my perspective, well, it is dealing with small scales optically. I mean, of course, it also includes some sort of nanoscale imaging with far field, of course. In the first place, I think it's something that tries to modify the field of light at very small scales using in the near field, using plasmonic interactions. So it's a kind of merger of material sciences and or solid state physics and optics. Well, very difficult to say, but I think conceptually a lot of work has been done already. So I may be mistaken. So there may be new great ideas out there that I don't see, but a lot of work needs to be done in order to get the microscopes going to an extent that they are easily applicable. That's not there out there. I mean, ideally, one would have to get away from fluorescence at some point and get a contrast mechanism working well for non-labeled features, materials, whatever, biological samples. That's a very tough problem to solve. And I think this has to be sorted out by a physicist again, and not by biologists or chemists. They won't come up, I believe, with something viable. And I think there's much to be gained if one comes up with alternative contrast modality, even if it has a limited range of usage. But that's something very desirable. I'm not sure, so I've not made up my mind. So the last project I worked on, this min flux, is now, I feel it like a culmination of the whole super resolution development over the last 20 years. And of course I want to still complete that work. It's not fully complete, there's still much room for improvement in terms of speed and saving photons. But once that's sorted out by us or by others who now jump on this development, I think I feel that I may have to move on to something else. And that could be something totally different.